Understanding entropy. The universal drive toward disorder in the study of physics and cosmology, few concepts are as fundamental or as daunting as entropy. While often discussed in complex mathematical terms, at its core, entropy describes a universal trend, the natural movement of the universe from order toward chaos. The building blocks of order. To understand how things fall apart, we must first understand how they are built. The universe is composed of various scales of organization. Atoms, the fundamental units of matter. An atom consists of a dense nucleus, protons and neutrons, surrounded by a cloud of orbiting electrons. Chemicals. When atoms bond together in fixed proportions, they create chemicals. A classic example is water, H2O, formed by the specific union of 2 hydrogen atoms and 1 oxygen atom. Stars. On a larger scale, gravity pulls vast clouds of gas together to form stars. These massive bodies serve as the primary building blocks of galaxies, emitting light and radiation as they burn. The mechanism of disruption entropy is the force that works against this organization. It is the measure of randomness or disorder within a system. In any closed system, energy tends to spread out and structures tend to break down. This process of disruption can occur through several cosmic mechanisms. Particle decay and randomness. On a microscopic level, particles do not always stay in predictable patterns. Randomness, the tendency for things to occur haphazardly rather than through a structured purpose, is a key driver of increasing entropy. As particles move and interact, they move from highly organized states toward more chaotic, disordered distributions. Cosmic catastrophes. The supernova. On a macroscopic scale, the disruption of order is often violent. When a star reaches the end of its life cycle, it may undergo a supernova, a catastrophic explosion that ejects most of its mass into space. While a star is a highly organized concentration of matter and energy, a supernova represents a massive leap in entropy. The explosion scatters atoms and particles across the cosmos, turning a single, structured entity into a vast, disorganized cloud of debris. Why entropy matters. The concept of entropy explains why time appears to move in only one direction. We see eggs break, stars explode, and chemicals dissipate, but we rarely see these processes spontaneously reverse. This arrow of time is dictated by the fact that the universe is constantly moving from a state of concentrated energy and order toward a state of maximum randomness. Entropy is not merely a scientific measurement. It is the cosmic rulebook that dictates the life cycle of everything from the smallest atom to the largest galaxy. In summary, entropy represents the inevitable transition of the universe from organized structures, like atoms and stars, toward a state of increasing randomness and disorder.